Hello guys, welcome back to SAP Learning Studio. I am Alex D'Souza, and in today's video we are going to build a purchase contract custom app using the RAP framework program model. So here's what we'll cover today. First I'll explain you about the tables, and I have already created two tables to keep this video as short as possible. And then we'll create CDS views, which are the interface views, the projection views, and the metadata extensions for the UI, and finally the service definition. And by the end of this video we'll have a real working Fiori app. So without wasting any time, let's begin. So before we begin, let me give you a quick context before we jump directly into the code. So a purchase contract is basically a legal agreement between your company and the supplier. It says we will buy this material in this quantity at this price over this period. And from the data structure point, a contract will always have two levels, that is a header level with the supplier date and the total values, and in the item table we will have the materials quantity and the price. So one header with many items, and it is like a classical parent and child relationship. So we are going to build an hierarchy level app, that is we will have a header as well as a child. So to keep this video simple, I have created two database tables. If you don't know how to create a database table, kindly watch my previous videos. And I have created a header table. And if you look at the annotations right at the top, so this is the label, and this is very important. It just gives the description of the table. And here it says the table is a transparent table. It means it is just a normal table. One row in ABAP equals to one row in the database. You'll use this for most of your custom tables you create. And we have created ABAP catalog.delivery class as a. Class A means it is an application data, and the users will be created this data at the runtime. SAP won't transport this as a test data. And the maintenance category, we have kept it as restricted, as it is not a table maintenance, and it is good for production level tables. And these are the fields. We have the supplier name, contract name, total value, and currency field, and this semantics dot amount dot currency code. And this is a currency amount, and its currency code lives in the currency field. And without this annotation, SAP won't format the numbers correctly in the UI. And abap.cur, that is 15,5, is 15 digits with two decimal places. And abap cur key, and this is SAP standard currency key type, and always use this and never use the plain characters. And we have these five fields, that is created by, created at, local last changed by, local last changed at, and last changed at. So these fields are the RAP admin fields, and these are very important in the RAP framework. And this will be filled automatically, and who has created the record, when was it last changed, and everything. You never fill these manually, and if we miss even one of them, RAP will throw an error during the activation. So always include all these five. Now let's go to the item table, and it is just similar to the header table. Same, everything is same. And I have also created some test data. This is the item test data, and this is the test data for header. Now let's quickly go and create our interface view. So navigate to our package, right click on the header, and this is a shortcut. You can directly click on your database table, and then based on this you can click on new data definition. And this is an interface view for header. And now click next, next. and we will create it as a root view. So select define root view entity and click on finish. Currently, let's comment this composition. We will be using composition and activate it. And now it will throw you an error. It says, okay, the reference annotation is missing. So it should have the same annotation as the currency, since it is a currency field. Always do a control space and let's activate this. So once this is activated, this is our base header view. Now let's create an item interface view as well. Right click on your database table and click on new data definition. And the I prefix stands as the interface. I have explained this in my previous videos as well. So interface view for item, click on next, and we'll click as define view entity and click on next again. Now here if you see, there will be an error for quantity reference, and in the item we have defined it as unit. So this is unit of measure. So let's come back and do a control space again and search for unit, and similarly for the net value. So this is a currency field. Now let's come and activate our item interface view as well. Now let's head back to our header CDS view, and now we have to join our item as well as our header tables together. So we will be using composition. So composition 1 to star, that is 1 to many, and the target name will be our item CDS view name. So let's come here and copy the CDS view and paste it here. This is composition of, and we have to give an alias. So we'll give the alias as item. So this is an item, and here in the end we have to give the association name as well, that is item. Now let's come here again to our item CDS view, and now here we have to give the relationship between the header as well as item. So here we need to define an association to parent. So let's give an association to parent. So this keyword will tell that it has a parent and child relationship. See, this is a keyword, and if you want you can just hover and read the documentation. And the parent is our parent CDS view, which is ZISLS underscore PCA underscore header. So this is our parent, and since this is a header, we'll give an alias as header, and we have to give a join condition, that is we have to use the projection dot on contract ID equal to underscore header dot contract ID. I'll explain the code line by line once we activate the code. And now once this is done, now we have to also define the underscore header down here, and now let's activate. Now once this is activated, since it did not have any relationship, it was throwing an error. Now once the item CDS view is activated, the error will be gone. Let's check it. If you see, the error is gone. Since the item, the child was not activated, the parent, there was no relationship between parent and child. Now let's activate this as well. So let's see the annotations as well. So this is access control dot authorization check not required. So this turns off the access control for now. So in real production projects, you should switch this to check. And if you just do a control space, you can see what all options we have. We have check as well. So we have a check as well, and if you want, you just can hover and read the documentation. For now, I have kept it as not allowed. So not required keeps the things simple. And if we see, we have defined it as a root view entity. So this is very important thing. The word root, this tells RAP that this is the top of the business object. The contract header is the root. And then we have the composition one to many at line number 5. So this defines the parent and child relationship. It means one header can have one or more items, and it means items cannot exist without a header. So this is how wrap model works. And underscore item is, as I said, is just an association name for navigation path, and we'll use it later. And the field list is straightforward. We are just using the database fields and the camel cases. So these are called as the camel cases. Database table and a lowercase with underscores, that are the CDS views used for camel cases. These, and it's a naming convention. And this exposes this underscore item. This exposes the navigation to association. Now let's come to our item CDS view, and it is just similar to our previous CDS view. Here, if you notice, we have not used any root view, since it is a child and child cannot be a root. And then we have used the association to parent. So this tells RAP that I belong to the header and my link is back through the contract ID. So this is the link. So the ID links it back. And the projection is the CDS keyword that refers to the current view and in the own field. So dollar projection dot contract ID means that the contract ID in this item is view itself. And the underscore header, if you see at the bottom, we have underscore header. So if you ever need to go back from item to its header, so we use this. Now let's quickly create a projection view for our CDS views as well. First, let's create a projection view for the header, and go to the data definition, right click, and click on new data definition. And since it is a consumption view, we'll start it with ZC underscore, and this would be the projection view for header. Click on next and click on next. So the ZC view, which is the projection view, this is what actually gets exposed to the UI. Think of it as a filtered consumption ready version of the interface view. And since we are creating a projection view, click on define view projection and click on finish. And this would give you a projection view. Here it shows an error to you and it says root keyword is missing. Since we are using the main interface view as a root view, if you see we have defined it as a root view, it says it's missing. So we need to define this as a root view. So let's add the root keyword, and once you mention this, again it will ask you to add the missing information, and it says the reference information is missing. That is nothing but the semantics for currency. And let's copy this from here. So whenever you use any currency or unit, you have to define these semantics, and it shows a warning, and it says to add provide contract transactional query, and just click it and activate it. I'll explain this part as well. First, let's finish writing our code. Similarly, we have to create one for item as well, one projection view for our item as well. Just replacing the I with C since it is a consumption view. And this is the projection for item. Click on next, click on next, and again select as define projection view and click on finish. Once this is done, if you see we have an error for unit, so we have to define the unit again. So adding these semantics is very important. Once this is done, activate your code. Now let's add the header and item navigation as well. So this is very important, adding the navigation. To add the navigation, we have to give a colon and add as redirect to composition child. And so this is the child which we have, and the child CDS view name. And similarly to header, we have to define as redirect to parent. Since header is the parent, we have to define it as parent and the parent view name. And now activate it. So meanwhile, I'll explain you the code. So the first thing you see, define root view as, and then we have a provide contractor transactional query, and this is a projection on this interface view. So this transactional query, this declares that this view supports full create, update and delete operations. If you need only read access, you would not use it. and as a projection on this CDS view name, and we are not reading direct from the database view, we are reading it from the projection on top of the interface view. There is an error, it says two parent and two child not defined. Now let me add it again. Comments code. The child CDS view needs to be activated first and then the parent. Now let's come and activate our CDS view. So once this header CDS view is item CDS view is activated, we have to come to our header CDS view and we have to edit this line as well, and we have to add a redirection to item. So this line says like the header can be redirected to the child and the child can be redirected to the item. Now let's quickly activate this as well. And once this is activated, we will have a redirection from a parent and child, and this is also called as redirection in the interface view, and this underscore item, this is pointed to the interface item CDS view, and here in the projection layer we direct it to the main CDS view, the projection layer, and this keeps everything consistent within the projection layer. And whereas in the item projection, this follows the same pattern, and the parent association is redirected to the header. Once this is done, our next step is creating a metadata extension. So to create a metadata extension, we should always use our projection layer. So right click on your projection layer and click on metadata extension, and let's copy this same name along with the prefix and metadata extension for header. Click on next, click on next, and we are going to use the annotate view template and click on finish. Just to save the time, I have a code snippet already saved for our metadata extension. I'll simply go and copy paste it and I'll explain you the code. And let's change. Okay, it says annotation metadata extension is missing in our projection view. So to simply fix this error, click on the error icon and click on add extension, and this will add an annotation saying that metadata extension is allowed. First you need to activate the CDS view and then the metadata extension. Meanwhile, I'll explain you the metadata extension. So this is the most favorite part, the metadata extension. This is where we control the entire Fiori UI using just annotations, and no custom UI development is needed. And let's go one by one through the metadata extension. As you see, the header info, this is the most important part, and this shows the header part of the screen, and the metadata layer as core. This layer tells the SAP who controls this metadata. Core means the base application layer, and this is correct for our custom app. And the header info controls what appears at the top of the object page in the Fiori, and this type name is the label shown on the object page, and type name plural is also used to show the list page title, and the title value which we are going to use as the contract ID means the contract ID will be shown in big bold title when you open the app. Next we have the UI facets, and facets define the selection on the object page. At first, if you see, we have identification reference. So this creates a form selection. The fields we annotate within UI identification will appear here. And the second facet is the line item reference, creates an embedded table inside the object page, and the target element would be the underscore item. So if you see, we have a targeted element underscore item, so this will show like a header and child relation when we open our application. And rest annotations, these are like for each of the field, each part that controls different part of the UI, meaning the selection field, this puts the fields in the filter bar on the first page, and then we have the line item and we have given it as a position 10. So this puts the field as in the column in the table, and then we have identification, and then this puts the field in the form of the object page. So with three annotations you can control the three different places in the UI, all from one field identification. That's the power of annotation driven development. Similarly, we have done for everything. Now let's activate this and quickly create a metadata extension for our item as well. Now let's click on our item consumption view and click on new metadata extension. And let's call this as metadata extension for item. Click on next, click on next, and click on annotate view and finish. Similarly, for item as well, I have created a template just to save some time. Again, it says add metadata annotation. Simply add the annotation and activate it. So this annotation is very important. So this will allow you to use UI annotations using metadata extensions. So the item metadata extension follows the same idea, that is UI line item for the item table columns and the UI identifications. This is similar to the one which I explained for the header. Now let's go and activate this as well. So the next part is service definition. We have to define the service, and finally the service definition, this is the most simple part. To define the service, we have to use our header consumption view and click on create new service definition, and this is the service definition. Click on next, click on next, and click on finish. In the service definition, you need to expose both header and item as well. So we'll do it manually. We'll add the item as well, and Once this is done, activate it. So these two lines, we expose both the projection views as a part of this OData service. And after creating this, you will create the service binding where you will bind the OData to V4 or V2 services and then publish it. And that generates the actual OData URL that the Fiori app uses. So now simply go under business services, right click on your service definition and click on service binding. So we are binding our entire code, our entire logic to this particular service. So this is the service binding for our application. We'll use OData V2 UI and click on next. It says it's not activated. Let's activate it again. And now click on finish. So once this is done, we have to activate our service, the service binding. And once a service binding is activated, click on the publish button. So our services are getting generated, and if you see down here, it's publishing the local services, and this usually takes like 2 or 3 minutes. Once your service is published, you'll see the entity set and associations. Now double click on the header, or you can simply click here and click on preview as well. And this is our application. When you click on go, you will have the list of contracts. And when I open any of the parent, if you see, you have a parent and a child relationship. So I can go inside and I can view the material as well. And if I click on this one, I'll just zoom my screen. If I click on this one, it will redirect me back to the parent. So that redirection code which we used, this is how it is used. So it will help us to redirect from parent to child and from child to parent. So this is our child, and we are able to redirect to the parent. And this is the header and parent relationship. So we have built a hierarchy level application. So alright guys, this is the complete purchase contract app from scratch. And just to summarize, we built two database tables, two interface CDS views, and two parent CDS views. And we also created our metadata extension for full Fiori UI services and the service definition to expose it to the OData services. And this is a complete wrap stack. And once you understand this pattern, you can apply it on any custom app in SAP. And I will update all the code on my GitHub. If this video helped you, please like, share, and subscribe to my channel so you don't miss the next one. Thank you.